This is the pendulum device that we created for our senior design project. The base of the pendulum that we used was a mill press. To create a pivot point, we used a metal rod, which we can see here, which was clamped down to the mill press using a C-clamp, which we can also see right here. To create a pendulum arm, we fastened a metal bar to the pivot point using frictionless washers and hose clamps. To the pendulum arm, we fastened our regulation softball with a screw, as we can see here. The bat that we used for this experiment was an aluminum softball bat, and it was attached to the mill press using the mill vise, which can be seen here. We clamped down the handle of the bat, as can be seen, and we are able to adjust the position of the bat using these mill table adjustments. So we are able to move the bat back and forth and have our pendulum arm hit the bat at different locations. For our testing methodology, we divided the bat into 4 distinct faces, each a 90-degree turn of the bat, which we can see here. And we created 5 positions along the bat that we wanted to hit. The first position that we created or established was this piece of blue tape that we can see here, marking the taper of the bat. And then we marked an additional 4 positions along the face, each face, which was 2 inches from each successive tape. And to measure the contact time between the bat and the ball, with the longest contact time establishing the sweet spot, we used an IMU NPU 9250 to measure the acceleration of the ball during the swing. And the IMU was fastened to the ball, as we can see here. The IMU was wired to an Allego Uno R3, which was connected to my computer, which ran our Arduino code, and serial printed the acceleration along the y-axis and gave us distinct timestamps that we were able to analyze and calculate the sweet spot of the bat. To collect data, the IMU was wired to an Allego Uno R3, which sent data to our serial monitor, which we can see here. Prior to collecting data, though, we first calibrated the IMU to get more accurate measurements. Upon calibration, we started our IMU code, which collected acceleration data and timestamps. We would have our ball on top of the bat, or initially at rest, and then we would pull the ball back, keep it at the top of the swing for a short period of time, and then release it so that it could hit the bat, and we caught the ball so that it would only produce 1 hit. And then after allowing the ball to come to rest after catching it, we would stop the code and import the data to MATLAB. And the MATLAB would then be able to calculate the contact time between the bat and the ball.
For data analysis, we plotted the acceleration along the y-axis versus the time index. The first orange line is the ball at rest, the second line is when the ball is being pulled back, and the third line is the ball at rest at its highest point before being released. Looking closer to where it makes contact, the negative acceleration is it indicates when the ball is being released, moving closer to the bat. The first point is when the ball makes contact with the bat, and then the positive acceleration indicates the ball being redirected, moving away from the bat. The last point is the end of the contact. So between these 2 points, we determined it to be the contact time. From the data collected from the trials, we were able to determine which position on the bat will produce the greatest contact time. As a result, the sweet spot on the bat was 8 inches from the taper for phase 1 and phase 2. However, phase 4 yielded different results. It indicated that the sweet spot was around 2 inches from the taper. Phase 3 indicated 2 sweet spots, one at 4 inches and the other at 8 inches from the taper. This discrepancy can be due to bats having different locations as sweet spots. Usually, the sweet spot must be defined as a region on the bat. From previous literature, we found that approximately 5 to 6 inches from the end of the barrel is the general sweet spot of wooden baseball bats. The results from our study might differ because the equipment we tested it on was a child's aluminum softball bat and softball instead of a regular wooden bat and baseball.